Hey, good afternoon, everyone. My name is Alex, and welcome to our Dalim Tips and Tricks webinar. This month, I will be demonstrating TWiST VisualCompare. Presentation is derived a lot from, there was a fantastic presentation Dalim did back in December at their worldwide technology meeting, which showed a little more under the hood than we've seen with this tool before. So really going to dive in deep, and I want to kind of take some of what Dalim showed and show it in more of a kind of production standpoint. So if you're new to our GoToWebinar series, there is a zoom button in the upper left-hand corner of the main GoToWebinar window. That will allow you to scale your screen if mine is too large or too small on yours. There is also a question area in the GoToWebinar control panel. If you have any questions about anything I'm discussing, then feel free to type them in there. We will be doing a Q&A at the end. However, if there is anything that's particularly relevant to a point I'm discussing at the moment a question comes in, I may pause to address it. As mentioned before, this is part of our monthly Dalim Tips and Tricks webinar series. We typically do one the third Wednesday of every month. We won't be doing one in April because that will coincide with Duo, which we're hosting in Vegas. But typically, I think from May onwards, whenever we know what we're doing for the webinars, we tend to push them up onto our website at blanchardsystems.com/events. So really what we're going to be going over today is kind of a continuation of what Dalim was showing at WWTM. I'm going to really do a deep dive into the VisualCompare tool, starting with some of the basic tool settings and configurations, the things you need to get this tool up and running in some sort of a compare workflow. Then we'll delve a little deeper into TWiST's difference detection algorithm and how it's actually determining those differences when comparing two files. After that, we'll move on to fine-tuning the difference scoring that VisualCompare uses to reduce false positives without reducing the kind of threshold of what you're checking. And then lastly, we'll talk about incorporating VisualCompare into a prepress workflow and a few different models for how you could take care of that. So if you're not familiar with VisualCompare or you haven't really used it before, VisualCompare is used to check some incoming file against a reference and look for any differences that might exist. This can be used, for example, to check to see if between two versions of a page to see if there's, for example, any different text or maybe a different photo. But what it most commonly is used for in TWiST is checking to see whether there's been some sort of artifacts introduced by a file processing workflow. Whether it's TWiST or RIP or GCR or some other third-party tool, once you're doing any heavy lifting with files, there is always a small but pervasive risk of introducing artifacts, particularly when you're doing something very intensive such as flattening. So VisualCompare most commonly is used as a QA tool of sorts in TWiST to make sure that nothing bad's going to make it to press. Now the way this works is VisualCompare takes, and this is kind of 1,000-foot overview, but VisualCompare takes in two files. First it takes an input file that you're going to be checking, and a second it takes in a reference file that's going to be used to compare against. Those are both fed into the VisualCompare tool. After that, inside VisualCompare, there's sort of a two-step scoring process that's used to determine whether the two files are different and to what extent if they are. The first step of this is if either of the files is vector, it's rasterized. If they're both vector, they're rasterized to whatever settings are in the tool. If one's CT and one's vector, the vector one will be rasterized to the same resolution as the existing CT one that was input. From there, it does a pixel by pixel comparison. It looks at each pixel and sees if they're different and how different. Now that's determined partially based on settings in the VisualCompare tool, which I'll show in a few minutes, but you can basically set a threshold or a delta difference between the pixels in those two documents that would be needed for it to be considered different. Once it's done that comparison, it kind of gives you a raw score, which shows you just how many different pixels there are in each of the two documents. And for most processes that do this sort of comparison, such as the older DiffCT tool TWiST used to have, That was kind of the end-all be-all of it, and that will give you a difference between the files. It will find anything that's different, but the caveat of that is it's a lot more sensitive to, I guess, false positives. It would really flag any differences, and that's been the problem with a lot of these sort of solutions in the past. Is you wind up with a lot of false positives because if you're doing any sort of normalization, converting color spaces or between ICC profiles, you're going to run into differences simply based off of the gamut of the color space or interference by things such as black point compensation. So the VisualCompare tool takes that a step further. After it gets that raw score, it looks at a set of about 4 different score modifiers and uses those to basically weight different parts of the score, depending on whether or not something is assumed to be an error. And there are some factory default settings in to account for just basically basic operation, but you can modify, and we'll dig into these a little more later, but you can modify these to either be more sensitive or less sensitive to different categories of differences that are detected in the file. But eventually it'll take the raw score, filter them through those modifiers, and then give you a final difference score. So I think the best way to really take this from here is to show the process, just the basic working of the tool in a workflow. So I have 2 files here we're going to be running through a workflow, but actually we'll open up the tool first and take a look in there. There's 3 tabs in here. The most important is this 3rd settings tab. And what this tab is going to do is, the main thing in here is you can define some kind of a tolerance or a delta to define how different those 2 pixels when it's doing a pixel by pixel comparison are. The terminology tends to change depending on some of the settings you choose in here, but it's essentially the same thing of you're choosing what kind of delta or what tolerance, what kind of difference there has to be between those 2 files for something to be considered different. If you start with 1, that would be extremely sensitive. Anything would really be considered different if there is any notable difference. If you set that to something higher like 80 or 90, it's going to take a more drastic difference between the pixels in those 2 files for it to be considered different. You do have the option to use on top of that, use or not use colorimetric comparison. What that will do is convert everything into a neutral LAB space before it does that pixel by pixel comparison. Basically how that would work is if you had a file that you had the original had a rich black and it was run through GCR, came out on the other end with another different rich black, and you had colorimetric comparison disabled, those would be considered different because the color composition of those pixels in the rich black is different. If you turn that on, they would both be converted to LAB for that comparison, and that black would look the same to the engine that's doing the calculation. So it'd be more really content rather than the specific makeup of that color makeup of that content. You do also have, as far as other options here, you can limit the analysis to just the trim box if you don't care about anything outside of the trim. And there is also one option here. This should always be checked, the use algorithm version 2.0. I think that's in there for compatibility reasons, but that's always one thing to check if you're getting weird behavior, because that should always be checked so you're using the latest version of the VisualCompare algorithm. Now, as far as some of the other tabs in here, you do have 3 different ways you can get your 2 files into this tool. The first and the most commonly used is this merge process here. And what that'll do is that we'll use a regular expression to search incoming files and find files that match this regular expression. So this would be looking for any file that begins with either check underscore or ref underscore, and then a common file name. Whichever one comes in with the check will be considered the incoming document to check. Whichever one comes in with ref would be considered the reference document. This can be customized if you have different naming standards. You do also have the options in here to define a preset reference, which what that would do is when a file comes in, it would save whatever came in as input files as the original, and then compare that against the processed file when it hits VisualCompare. There's also the document ed option in here, which will allow you to specify a folder on the file system which contain the reference documents you wanted to compare against. And the last tab, Behavior, there's not too much goodies over here, but this allows you to control what happens if there is a warning or an error flagged in a file. warnings or errors just being different severities of how different those files are. Then you can also have, so you can have, for example, enter in a work item if you need someone to manually approve it in TWiST. You can have it output a report to a location so that you have a difference report of what was different between those files. You can have a JDF generated if you wanted to, and you can even have it, most of the default settings in here are fine, but you could even have it store the results in a variable so you can use that and act on that later in the workflow like I am here, where it goes to a not okay branch if the file fails compare and an okay branch if it's good. But that's about the gist of that. So I have two test files here we're going to run through. This just is a really bare bones demo to get started. What these are going to do is, let me zoom out so we can actually see these. So these are kind of the same file with one or two tweaks in here. So I think you can see it pretty good here. These files have the date is different down here. These rules are at different positions. And then I actually took this image into Camera Raw, and on this check one that we're going to check, I deliberately blew out some of the highlights. So there's some clipping and some loss of image data there so that we do have a significant enough difference that we can go ahead and flag that. So what we'll do here is, let me see what a delta E is here. Okay, I'm running with a delta E of 10, which is pretty, actually I'll go with 15. That might be a little too intense for this one. So I'm going to take these two files, and they're both pre-named with the check and the ref in the front of the name so that it knows which ones we're going to drop in here. I don't think that took, there we go. So those are both going to drop in. Those processes are actually going to merge, and it's going to run through the VisualCompare routine. And since we're checking this at a very low delta, it's going to flag that file and might take a minute longer to compare since we're looking at such a low threshold here. Okay, and it's going to go to work item. So if I go up to my Windows work items and click my play icon here, it's going to open in Acrobat a difference report PDF. And also give me the option to approve or reject that difference report in here. What this would be really useful for is if you had a scenario where you wanted to absolutely make sure something got flagged, that someone checked it before it moved onwards in the workflow. That being said, you don't have to do it this way. I find this a little cumbersome personally, so you might prefer to have it just drop it into a folder on a network share, for example, like this workflow is also doing, so that you don't have to manually approve that in a work item. But we'll see here we have our difference report, and there's a few different things in here. The first is we have both the check and the reference files as examples. These are just rasterized JPEGs in here, but you can see if I toggle it changes, I can see each of the two files and compare between them. All these things are in different layers. I can actually hide both these if I want to see just the errors. It highlights them all. They're color-coded by severity. The blue are the least severe. They're the most similar to the. They're different from the original, but not so different. The orange is a little more severe. Red means there's a pretty significant difference there. But I can check those if I actually zoom in down here. If you really want to, there's more options in here. So I can just see just the error, for example. If I want to see, it'll show me just the pixels that are different, which I can see pretty clearly. There's also an error exaggerated option here, which is incredibly useful for being able to, if you have something that's maybe a small area that's flagged, that kind of highlights the area around the error. So if you have something that's small in there, it's a little more easy to identify. So let me actually go up here, and we can see up here we got a lot flagged towards the top where we had those highlights were kind of clipped out in my check file. So you can see there was a lot flagged in there. Now, to show how the delta E works here, if I go in here and let's say I change this to something a little higher like 75, it's going to require a much more significant difference before it flags that as a difference. So I'll take these same two files, just running with a different delta here. And there we go, we have a report. So we look at it this time, this one with that delta of 75, where it has a much higher tolerance for difference. It's only highlighting the most severe issues in here. A lot of those highlights up here were more subtle of a change. Those aren't being flagged now, but the more egregious errors down here, such as the change in year and the difference with that rule line here, are noted. So generally, if you were going to put this into a production workflow of some sort, the best place to start would be to find a few example files you might have had issues with that had some sort of an artifact generated by flattening or processing in your production workflow. And those and a few other files that are known good. And by running those through, you can kind of tweak the delta E to get it to a point where it's flagging the files that do get artifacts, but you're not getting a high percentage of false positives. And you can use that to kind of get a good baseline for where you need that VisualCompare tool settings tweaked to. Now, once you've done that, if you are getting some false positives, because false positives do happen occasionally, you do have these score modifiers that you can use as an extra kind of tweak here to control things. So how those really work is, and there's parameters here. I have each of the different score modifiers. We'll go through them each one by one, as well as there are parameters you can use if you go into the expert editing in TWiST that you can use to tweak how sensitive or forgiving it is of each of these detected different types. So the first here is anti-aliasing. So that would really be, for example, like text smoothing when you're converting to a JPEG. TWiST can determine this difference algorithm can determine when a difference is likely to be due to anti-aliasing. An example of that would be something like this, these two test files I have here, which we'll run through TWiST in a few minutes, but I have one here that's pretty much a standard just JPEG with some text in it. That's pretty sharp. The one down here has had some blurring or some anti-aliasing applied to it, so it looks a little smoother on screen. So we can see if, as I click on the wrong thing here, 1 second. So we can see here with these files, not having much luck resizing a window here. It's my great struggle for the day. But you can kind of see here the kind of arc of this S. The one that's had that blurring or the anti-aliasing, the pixels are pretty notably different between these two. TWiST can determine those patterns, can detect those patterns, and determine that it is a difference, but it's a difference related to anti-aliasing. And from there, you can tweak the settings so that this aliasing ponderation factor, it's set by default to, I believe, 50. If you set it to 0, it is going to be completely unforgiving of anything that it determines as a difference due to anti-aliasing. If you set that to 100, it will be completely forgiving of anything it detects as anti-aliasing. And it uses these modifiers to adjust that initial raw difference score it gets by doing the pixel-to-pixel comparison. So if you're in a scenario where you don't want things being flagged for anti-aliasing, you can bump that parameter up to 70, 80, 100 to catch other kinds of errors, but not the errors related to, or the differences related to anti-aliasing. Similar, I don't have a good example to show for this one specifically, but the local offset would be if you're in a situation where you're flattening a file perhaps, and you have a whole bit of content that gets shifted by 1 pixel. You might not want everything that gets shifted by 1 pixel, even if that's a lot of content, to be flagged as an issue. The local offset options here will allow you can basically have TWiST detect when pixels have been shifted up to 4 pixels, and then decide whether or not you want that to be, how you want that to be weighted when comparing those differences between those files. So again, 0 would be very unforgiving of anything it detects as a 1 or 2 pixel offset. 100 would be very forgiving, and you can set here how far it will go to search for that offset. The default's 1, so it'll search for a 1 pixel offset. You can set that so that it searches all the way for 4 pixel offsets, although that might take a little more processing time. Next would be noisy and uniform areas. Run a check to see, basically you can control how it weights differences found in either noisy areas or uniform areas. I'm using the same 1 to 100 scale again. Let me pull up a file here as an example. So an example of a uniform area would be something like this down here, where there's not a lot going on. And let me pull up, I think I have another file here, which would be a pretty decent example of noisy. Yeah, here we go. So something like this fruit here. If I really zoom in, that would be an example of something noisy. There is by default a lot of differences in the pixels. These aren't all some uniform color like this other example over here. But you can control for either noisy or uniform areas how forgiving it is of differences in those areas on that scale of 1 to 100. Maybe I'm in a situation where something like this, if there's a few pixels in here that are different, I don't care as much because it's already a pretty noisy area, so it's not going to be quite as noticeable, whereas I might want to bump it up for something like this, where if there's a bunch of pixels in here that are slightly different, it might be much more noticeable based on how uniform this area is and how little's going on in here visually. So you can control those as well. And the last one in here is the dilate factor and error propagation. And what that error propagation is there's an algorithm in here that goes through the file as part of that score modification. And it looks at how closely together errors or differences are clustered. So it looks to see if, and by default, if you set this is set by default to 3. It's kind of an arbitrary number based on, I guess, levels of how much of this check it runs. But if you set it to 0, it's going to take everything at face value. A difference in some area, a difference all by itself in one area. Maybe I had something down here in the lower left corner by itself, and I have 5 or 6 different errors or differences up here. It's going to both take them at face value. If you increase that number to 3 or 4 or some higher number, what it's going to do is it's going to weight based on the number of areas within a given chunk. So if there's one pixel that's different down here, that won't be considered as severe of a difference as something up here where you might have 5 or 6 pixels together that are all different. It'll assign more weight to that when coming up with that final difference score. So a lot of technical jargon there. One good example of it will actually be those anti-aliasing files I had there. Let me pull up my workflow. So I have my workflow here. There is an option in here. Let me actually change that real quick. So there's an option in here in VisualCompare. If you go to expert editing, then you can use this to modify individual parameters of the tool, including, there was the one I just tweaked in here, this, I think I lost it now, aliasing ponderation factor. That's set to 0 right now, so it's going to be very unforgiving of any anti-aliasing errors. And to exacerbate that, let's bump this down to delta of 10, so it's going to be really unforgiving. So if I take my example files, I have 2 JPEGs here. And these are the 2 I was showing earlier. This one is a little blurrier from anti-aliasing. This one's sharp. If I take these 2 and run these into this workflow, they're going to get flagged as different and significantly different. So we can see we just had a report pop in here, and sure enough, it did flag the outside edges on this file, because that one's pretty blurry compared to the other. And it did flag all that. But if I go back in here, back into expert editing, and I tweak this so that the aliasing ponderation factor is 100, it's not going to let me, let's try this. As I click on the wrong workflow. Here we go. Aliasing ponderation factor. Let's change that to 100 so it's extremely forgiving. We're not changing the delta at all, so it's still going to be delta of 10, where it's looking for a very fine-grained sort of change, or a very fine-grained difference between those files. So if I dump those 2 back in here, this time it's not going to flag them. So that went straight to OK. Because we tweak those settings, it's not going to see it as different. Another example of this, I did get 2 test files from Dalim which show this as well. They actually did a pretty fancy workflow for this. So what I'm going to do is I'm going to dump both these files in here. These take a bit to run, so we'll talk about what's going on as they run through. So I do have 2 files. This is one case where these are just 2 separate files. They're not a check and a ref file, but there's a lot visually going on in these files, and there's a few different errors it's going to, or a few different differences it's going to flag. Now in their workflow, the way they have this set up, there's a special pre-built program link that TWiST has baked in called VisualCompare create reference. And what that'll do is when the file comes down this way, it'll automatically take this as the reference file in this comparison, so that whatever comes through this way will be considered the check, this will be considered the ref, even though I only dumped 1 file into that technically. Now on top of that, this one check file is being run through PDF renderer, so it's being converted to, I think, a TIFF and being rasterized, while as that one's being preserved as vector content. And this one I think does have some anti-aliasing being put in by the PDF renderer tool. So these 2 files are going to have a few minor differences flagged in them. Okay, yep, we got our 2 files. I got 2 reports here. So we'll see here, for example, I think in this one, the issue is right up here. It was just flagging a tiny bit of that 4. Because again, one of those was rasterized ahead of time. Now if we go over here, this other one is, we have another tiny error down here, which if that's something perhaps we don't want to flag, what we can do is go into this tool, right-click, Expert Editing, and what we're going to change here is there are 3, if I can find them. Which is what I typically like to do for this because it's hard to search in there. And I'll just open Text Wrangler and search, pull my search screen over here. So we'll change Shift Ponderation Factor to 100. We'll search for noisy area ponderation factor. Let's change that to 100. And then there's another shift direction range in here. And we'll change that to 2. I'll actually take all this and I'll paste it right back into here so I don't have a 2 hunt for those. And I'll save the workflow. And we'll dump those files back in, and this time they shouldn't get flagged. So we'll dump those 2. While they're doing that, I'm just going to check and make sure my change took. Yep. So both those files made it past the VisualCompare and to the validator at the end of the workflow. And if I look at the logs here, you'll see this time that there was no difference detected. So that's one way where basically the best way to look at it would be you use the delta E or the tolerance to kind of zero in on what gives you the best mix of that catches all your problematic or files that had artifacts introduced, but doesn't give you too many false positives. Then for those false positives, if they become a problem, you can use those 5 individual score, the 4 individual score modifiers to tweak things just a little more to help prevent false positives from showing up. So I know we're running pretty short on time. There is one last thing I do want to show real quick, though. I have 3 examples of how this could be baked into a production workflow. There isn't really a right answer here, but these are just 3 different ways depending on your needs and your specific workflow setup. So the first one here is just a basic normalize. This is a pretty straightforward, just vanilla prepress workflow here. File comes in, gets normalized in PS check, gets trapped, gets run through OPDF and output as an X1A, and then stashed somewhere for the press or for imposition. I do have in here another branch coming off that's going to go to VisualCompare. And this is set to use the preset reference. So it's going to use whatever the input file was as my reference, and this final processed press file is my check file. And I just put in here OK and not OK branches, but you could have those go to different places and perform some sort of an action if a bad file is found, for example, to alert the pressman. So what I'll do is I have a file on my desktop here. Let me just dump that in real quick. And so that's a pretty straightforward workflow. But something like this might not be the most pragmatic option if you're in a situation where, for example, you need to you want to reuse that VisualCompare with multiple workflows, or you have some other work that needs to be done on the file after the step, and you don't want to kind of have it all baked into just one big workflow. So yeah, this finished up. That was pretty quick and straightforward. I have a second example here, which what this does is same workflow, but at the very beginning, it stashes a reference file. It branches actually to another workflow called Do the Compare, and it renames the file to add the ref at the beginning to let that workflow know that this is the reference file. There's one more of these at the end, which branches the same workflow and adds a check at the front. And it's worth noting, I could have put this transmit up here between the input files and PS check, but I made the decision to put that as a separate branch, so if I ran into a situation where the transmit failed due to a server issue, I don't want the whole workflow to fail, because the QA process is really secondary to that core file processing. So yep, what that'll do is I'll dump a file in here. There's a do compare to. It's pretty straightforward. It just goes to VisualCompare, pulls in the 2 files, and if something is different, it will launch a work item. And I do have 1/3 variation of that as well, which is a little trickier here. You can see that branched off to do the compare to. Now, this third one is very similar setup. I do have a few other tricks in my sleeve because the one downside to doing something like this where you branch to another workflow and send those 2 files in is if the reference gets there and this press PDF never makes it, it fails in trap, for example, it can't trap it, you run into a situation where you could have a bunch of those reference files waiting for the check file to come in and just cluttering up your process window and editor. So the one thing you could do in this case is I have it branching off to a folder. So it's storing these in Symlinks IO jobs, webinar, QA refs. And this check over here is just doing the same thing it was in the last workflow, branching to another workflow. I do have one more step in here since we're transmitting this to a file system. I don't want to run into a scenario where it picks up the wrong edition of a file. Maybe I uploaded one copy of this and it failed in this workflow. I don't want the next one that comes through to pick up that old copy for some reason. So I have a set param array here that's just setting a variable my timestamp to the current time in milliseconds so that we can kind of make that unique. And it's using that when it renames these files. Then do the compare 3 over here. It's branching to this workflow at the very end, which is pretty simple. The same kind of VisualCompare. It is using the document at method here to go to that folder and look for the reference file and then pull that in. So the only thing that's ever going to hit this workflow and start it is that final press ready PDF. Now this also has one more trick in here. I have those 2 branches again, but if the file is bad, it's going to send me a mail that has actually some nice HTML in here, but it's going to send me a mail telling me that there was an issue and telling me a little bit about it. So let me run that file through one more time here. And so it sees there's an error and it's sending me a mail. If I actually look at my file system over here while I wait for that mail to pop in, you'll see that now we also have a folder for those QA refs, and some of those got stashed in that folder. If you were going to implement this in a production workflow, you'd probably need a step after here that deletes them when it's done with them, so that they don't just clutter up, continue to clutter up space. But let's see if we get our email here. Yes, we do. So we just got an email here just this minute. It has the name of the file, failed VisualCompare. I have my error count, I have my warning count, and a link to the path for my difference report. So that's about the gist of VisualCompare. Hopefully that was helpful. Does anyone have any questions?
Yeah, thanks, Alex. I think that was pretty informative. It's interesting to see how they use all those different settings to kind of tweak it, because over the years we have had a lot of customers ask about any way to tweak it. Just using Delta E doesn't always help. So very well done. We do have a couple questions. The first question is basically a licensing question. What license options are needed to use these features? Let's see. Pretty much from what Alex showed today, VisualCompare is a standard TWiST tool. So if you have TWiST, you do have access to the VisualCompare tool. The thing that would be licensed would be if you want to use the PDF compare or the Adobe Print Engine to do the rasterizations for you. That's obviously licensed. But the VisualCompare itself, to just use it with files from a RIP or something, is a basic tool. The other question I have, there's only two questions today, so at least I have. The other question is basically how this can be used with ES. I'm not sure, I don't remember if Alex showed the to treat or the work item, but basically if you're using eTwist workflow with this, and it has to be eTwist, not regular twist, the work item will become available for you inside of ES itself. So the file will just show up as if it's an approval state. You hit the check mark for the approval button. Like if you're approving it on a normal approval, it will actually bring up the work item so you can look at the errors and then approve it and move it forward. I believe you can also send the JDF report, if you want to build your workflow that way, into it as just a pre-flight report with the errors in it. And then stop it if it shows that you have that error on your own outside of the work item. But the work item thing has always been a little bit flaky, I think. I like that. Most of my customers using it, and yes, I've seen are using the JDF report itself and just using it basically as a pre-flight stop.
Yeah, it's also worth noting too that in ES, the HTML dialog engine does have a compare function which uses the same VisualCompare engine, and a lot of the options are quite similar. So you have the same option in the ES interface. If you're in dialog, you can pull up a comparison between two revisions or two documents, and it's the same Delta E terminology. There's the same color metric option. So it really does the same thing under the hood. It's just there you're using it to compare perhaps two revisions rather than to look for artifacts that were introduced by processing.
Right. Yep. And that's all the questions. So everybody, thank you for attending today. Again, email link will go out if you want to watch this recorded and go back to some of the stuff. You should get that about the same time tomorrow. Again, hopefully we'll see you at Duo this year in Vegas. If not, we'll have another webinar, which will probably be a Duo recap, third Wednesday of May. Everybody have a great day. Thanks a lot.